Come on, multi-agent AI? That's hype. That's going to be a waste of money. That's what I thought, until I saw this research from Anthropic showing how Claude Opus and Sonnet beat a single model by 90% on complex research tasks. Turns out that multi-agent systems not only can go faster, they can actually think better. Let me dig into this. What we have here is how Anthropic built a research assistant using 3 different types of agents. There's a head agent, which is Claude Opus, that plans out all the research. Then you have sub-agents that handle specific tasks. And finally, a citation agent that compiles all the sources. But you can think of this as the research team, where a manager is going to delegate out to specialists. The specialists are going to do their task. The manager is then going to synthesize all these findings. So like splitting this task into parallel helps explain why things are faster. But why is it more accurate? Well, it turns out by distributing the tasks across agents, each one is going to have its own clean context window, its own input, there's no clutter, it can focus on each sub-agent task. So it's essentially a capacity multiplier for working on these problems. Now this works great for these parallel task problems, research style problems, where we have this breadth. But not all problems are like that. Some problems you need the depth, and the multi-agent approach isn't going to work as well. And you can see this in the prompt that Anthropic writes around this. Now, figuring out how to do all of this, when to use what type of prompt, is now what Harrison Chase is calling context engineering. And this is how we're going to start working with these models. Not just thinking about the prompts, but engineering how all of these agents work together and what they see.